So now on, we'll move on discussing with from the questions from 11 up to 20. Finally, in the last video, we finished discussing the 10th MCQ of the 2001 Physics MCQ paper. So now we'll move on with the 11th question, that is measurements related to dimensions. So the expression that they have given is, this is the 11th question. V, I and J are vector representations. If we, for example, I is represented by the y-axis, whereas J is represented by the x-axis. So that's the ij representation, and this later you've learned that, especially mathematics students will know that it would be the z direction. So that's no need in this part, but no need of such concepts here, but it's better to know them for better benefits. Give me a second. Yeah. So let's move on directly with the question itself. Vi equals to KAJS. So here we'll write them in a dimensional format, that is in this particular way, equals K constant in its dimensions and into A in its dimensions into J into S in its dimensions. So the dimensions of velocity is LT minus 1. Within brackets we have to put I like this, and then K is is dimensionless, so no need of that K. Acceleration dimensions LT minus 2 into it should out of the bracket J. Then S is as they have given I and J are integers, and S represents the displacement. So S is displacement, we represent it in L. So now Li T minus I equals Lj T minus 2j into L. So the constant K has to be considered as a dimensionless constant. If K has dimensions, this problem cannot be solved. So considering the indices of L, I'll underline each L term here. So L, I equals J. Here the power is exactly 1, right? Though we do not write it as 1, we can write 1 there. J plus 1. So when we consider the terms T, I'll take another color, T. So for T, minus I equals minus 2j, right? So thereby this J here equals to, we can say that J here equals to minus to I cancel, minus cancel, so thereby I equals 2j. Here substitute directly, 2j equals j plus 1, thereby j equals 1. Then substitute for I equals 2 into 1, thereby I equals to 2. So I and j values, we have found them already. Thereby what's the order? I and j respectively is equal to 2, 1. That is the answer number 3. This is our answer. So 3 is our answer here. Now we move on to the question number 12. A train travels along a straight track. Another train travels in the same direction behind the first at the same speed. The first train blows a whistle of frequency F0 if the apparent frequency of the whistle heard by the stationary passenger sitting in the second train is F. Then, when dealing with the question number 12, since the train with the observer and the train in front to the observer move at the same speed, so it's already visible or it's already comprehensible that these two motions do not have any relative motion in between. Between the source and the the observer can hear the frequency of the source itself. Hence the answer should be equal, like both the frequencies should be equal. If there is indeed a relative motion in between, then there should be this concept greater than or equal or greater equal concepts. So here it already should F should already be equal to F0. That's all. So answer is 3. We catch this concept like when this is the scenario is easily understood by that it says at same speed. This term helps us to identify or detect the answer quite easily. So now onwards we'll move towards the 13th question, that is let's read the question. A 50 cm long hollow cylindrical tube open at both ends is placed in a sound source that produces pure tones is placed adjacent to one end of the tube. The frequency of the emitter's sound is increased gradually, starting from a very low value. At a frequency of 320 Hz, the tube resonates. The speed of sound in air is. When dealing with this kind of a question, this question is related to oscillations and waves, and under that also it comes exactly under vibrations of tubes. So let's directly approach the concept behind this. Question number 13, right? Question number 13. According to V equals F lambda, the common equation you get in waves and oscillations, the value of lambda gradually decreases as the F value gradually increases. As F increases, the lambda value decreases. That's obvious, right? Yeah. So, keeping the V constant, in that case, this V is a constant. Therefore, at the first resonance, there should be a stationary wave with the maximum wavelength in the tube. Right? So during the next resonance, the value of lambda gradually decreases. So the first resonance is commonly called as the fundamental. If we draw a resonance tube like this is what we call a open tube. Both ends are open. Okay, closed tube in the sense only one end is open. So in open tube, as they have given in the question, you should draw this. You must be able to draw the fundamental state. There should not be any what we call these loops. There should not be a single loop drawn inside. So that means it has to be something like this. No loops. Okay, you can't see any loops here. So the length of this is 50 centimeters. Let's consider this whole length as L. Afterwards, L equals lambda divided by 2. One part is lambda, right? Lambda divided by 2. So lambda equals 2L. That means when we substitute V equals F lambda, according to V equals F lambda, V equals to F is 2LF, right? So velocity again equals 2 into L is 50 centimeters. Frequency they have given as 320 Hertz. Again, we must convert these centimeters into centimeters. So V equals F lambda, substitute this again in here. V equals F lambda, V equals F into 2L, V equals frequency 320 into 2 into 50 centimeters, 320 into 2 into 0.5 meters. You must be able to convert this to meters, and then final answer is 320 ms minus 1 is the velocity. Next question, number 14. The velocity of sound, give me one second. So, the velocity of sound in a gas at 27 degrees Celsius is V. Question number 14. At 27 degrees Celsius, the velocity is V. The temperature at which the velocity of sound in the gas becomes 2V. They are asking what is the temperature. In these kinds of questions, it's indeed a must to convert this Celsius into Kelvin. So the major equation that we are dealing in oscillations and waves, and also related to sound, suppose that the temperature at which the sound speed doubles is unknown. Let's name it as T degrees Celsius. We are unaware of this. So the sound velocity in the air in the first instance should be calculated. So we should be able to get two separate equations and then divide, like we will name those two equations as equation number 1, equation number 2, and then divide it by, and then find the unknown term that which comes finally after a simplification. So V equals gamma RT divided by M. We will define these terms respectively. Gamma, so gamma RT divided by M. Molar mass of the gas is absolute temperature of the gas. R is the what do we call the yes. So once we simplify this, we will substitute this in our first equation. V equals gamma is a constant, R is a constant. Here T value here is actually 27 plus 273, that is 300. Here our unknown temperature is T plus 273. We don't know that. So here gamma RT into 300 divided by M. We are not given any data about the particular gas. This is our first equation. Then they say that finally it becomes as 2V. Here gamma RT is T plus 273 divided by the molar mass of the gas. That is the equation number 2. Once we divide equation number 2 by 1, we get 2V divided by V, T plus 273 divided by 300. That is that you should be getting a square root like this, and then V to V cancels off. This whole thing should be twice than that of this particular expression. So twice 2 4, then the root is removed, T plus 273 divided by 300, thereby the value of T you get as 927 degrees Celsius. Okay, that is Celsius. So in kelvins you would be getting 1200 kelvins by simplifying this, but actually what you will be getting is the absolute temperature value in kelvins, but later you should be able to convert it to Celsius by reducing 273, thereby you get 927 degrees Celsius. So the answer is 927, answer number 4. Question number 5. A convex lens of focal length 25 centimeters is kept in contact with the concave lens of focal length 10 centimeters. The power of the lens combination in diopters. This particular question is related to oscillations and waves and the optical parts, and under that even the lenses, under the topic lenses. So when finding the focal length or the for the focal length or the combination of the focal lengths, we have equation. Composite focal length is question number 15. Question number 15. Question number 15. We have composite focal length. The equation, major equation we get is 1 over f naught. Therefore the composite lens, the focal length for the composite lenses, and then the 1 over f. Since there are several lenses here, each lens should have each focal length. Okay, this is the equation. We can add even more since they are talking about two particular focal lengths for two specific lenses. This is just sufficient. So now we are unaware of the composite focal length. First one is a convex lens of focal length 25 cm. Convex lenses are negative, right? 1 divided by minus 25 applied in centimeters is quite fine. So plus the concave lens is 10 centimeters. Once you simplify this, you get 1 over f naught divided by 55 minus 2 then you get 3 by 50. Thereby turn this upside down, that means 50 divided by 3. F naught is 50 divided by 3. Then combination in power of the lengths combination in diopters. So the length combination power, now for the combination focal length is fine. Now the power. For the power we know P equals 100 divided by F naught. Thereby 100 divided by 50 divided by 30. 100 into 3 divided by 50 cancels off and 6 diopters. Answer is number 2. Here we get it as 100 because centimeter values is in 100. Also we can also write in P equals 1 over F. Since this is centimeter given value, we should be able to convert into meters. So that's all. Question number 16. Question number 16. We are coming. The viscous force acting on a sphere moving in a fluid is. So now this comes under the lesson properties of matter. Under that there are 3 categories that you'll be studying, that is elasticity, viscosity and surface tension. Here we are dealing with viscosity. Question number 16, viscosity. The major equation for which a viscous force acting on a sphere moving in a fluid. Stokes' law, that is a concept that you'll be getting under viscosity. This particular Stokes' law is used to find the viscosity force F. The viscosity coefficient is N like symbol, we represent it like that. The radius of the sphere is defined as A, then it travels at velocity v, that is F equals 6 phi coefficient of viscosity into radius into velocity. According to the above equation, the viscosity force is directly proportional to the velocity of the sphere. That means F is directly proportional to v. So the statement A is true. B, directly proportional to the mass of the sphere. Statement B is false, right? Then we do not talk about a mass here. So we see velocity, radius, velocity, radius and the viscous force. Viscous force are the symbols that we are dealing with. So coefficient of viscosity is quite fine, that is indeed is a constant. So the force F is proportional to the radius of the sphere. So statement C, inversely proportional to the radius of the sphere. No, it is directly proportional, not inversely proportional. So that is false. C is false. B is also false. Let's see what would be the correct answer here. So my guess is that number 1, that particular part is not printed. The number 1 here, answer for the number 1 is only the A statement is correct, right? A only. That is our answer. Now we will be discussing the question number 17. A monochromatic ray of light undergoes a minimum deviation after passing through a prism. If the angle of deviation produced by one of the prism surface is 20 degrees, the angle of minimum deviation of the ray. This particular lesson for question number 17 is what we are dealing under refraction of light under oscillations and waves. At the minimum deviation, the light ray travels symmetrically in the prism. If we draw a prism like this, sorry about my diagrams, just ignore the straightforwardness in drawing the diagrams. This is how the ray passes. It passes symmetrically, and this is 90 degrees normal line at the minimum deviation. At minimum deviation, this is how we draw the ray diagram. So in other words, the ray in the prism is parallel to the third base of the prism. These two are parallel, okay. In such a case, the deviation of the second surface is also 20. A deviation is, now since the light ray should actually be moving like this, no, so it actually moves in this way. So the deviation here is, this is the deviation. So here the deviation is mentioned as 20, hence the other side also the light ray must pass like this. Here also the deviation is 20, because at minimum deviation this is the symmetrical way of, that is the symmetrical way of in the passing traveling of the light rays, in which the way in which the light travels is symmetrical. So in such a case, the deviation of the second surface is also 20 degrees. So thereby the total deviation, if we say this deviation is d1, this deviation is d2, the total deviation, let's represent it in capital D, d1 plus d2. That means 20 degrees plus 20 degrees, the total deviation is 40 degrees. Question number 18. A person who is lone-sighted has near point at 50 centimeters. What spectacles are required for him to wave objects comfortably at 25 centimeters? At the 25 centimeters, in the sense that's the normal distinct vision, normal distance of distinct vision. So here we can use the equation, major equation used in optics, the lens equation. So question number 18, we can use 1 divided by f equals 1 divided by v, here plus 1 divided by u. That's the equation we use in optics. The lens of the spectacles makes an image at distance of 50 centimeters. So the image quite fine at 50 centimeters. This we use as the image. For the image distance, this is for the object distance. 1 over f divided by 1 over 50. Since the for objects that distance of 25 centimeter visible to him, let's apply the lens formula to the lens of the eyeglass. So that is, since it's the real object comes from the opposite side, not in the direction which the light travels, it has to be a negative. So it is minus 1 divided by 25. Once you simplify this, 1 over f is minus 1 divided by 50, thereby f equals minus 50 centimeters. Since there's a negative sign here, it must be a convex lens, because only convex lenses have negative focal length. Hence the answer is number 3. Question number 20. Our final question for the today's session. Relative humidity inside a closed chamber can be increased by relative humidity. This comes under the lesson heat, under the section humidity. So you'll be learning deeper concepts under the topics relative humidity, absolute humidity, and so on. So since this is a kind of logical thinking based question, we don't need to deal with those equations here. We'll be later discussing them in detail, but in this question, let's just discuss in which way can we approach this answer even for a student who is not who has not completed the theory parts, even can understand and answer this question quite easily. Just by observing the day-to-day scenarios. As more vapor enters the chamber, what happens? The water vapor density in the chamber gradually increases, right? This increment, more water vapor in the sense, more water vapor inside a chamber means water vapor density increases. Don't get fooled by these scientific terms. Water vapor density or the concentration increases. Thereby it reaches the level of saturation. Saturation level is that's the maximum situation where the water can exist in its gaseous form. After it exceeds the level of saturation, it gets condensed and comes to the surface and comes in par with the other water molecules and changes its state, right? That is when if saturated, the relative humidity becomes 100%. At saturation level in the sense is relative humidity equals 100%. That's the exact thing what I said before. It can no longer bear the gaseous water molecules. It falls down. That's a maximum level which you could perform. Afterwards you come back down. You can't go up and up and up like that. So you will exactly come to the initial positions where you were. So like this, after it exceeds the 100%, it can no longer stay in that format. It will reach downwards to the surface. Therefore, the statement A is adding water vapor to the chamber. What they ask is how they could increase the relative humidity inside a closed chamber. Adding water vapor to the chamber. That indeed is correct. More you add water, higher is saturation level. By the B statement, by decreasing the temperature inside the chamber. Decrease in the temperature. How are we supposed to resolve that? The amount of water vapor required to saturate at low temperature is low. For water vapor to become saturated, we need higher temperatures. The amount of water vapor required to saturate at low temperatures is low. Therefore, as temperature decreases, it gradually becomes saturated. B is correct. More you decrease the temperature, the relative humidity inside the closed chamber increases. gradually, right? By decreasing the temperature. You see the dew formation. When still during the mornings, even though the sun hasn't risen fully, the dew is observed. So that means that temperature is kind of at low levels. So thereby the humidity levels in the atmosphere is also increased. Thereby only the dew formation occurs because the surrounding temperature is in this decreased kind of a level. Value. So by decreasing the temperature, relative humidity can indeed be increased. By decreasing the volume of the chamber. Yes, if there is a big vessel like this, you should try much harder to give a maximum saturation or maximum concentration. You must give its full potential. But if it's a tiny box, just with little effort, you are able to saturate this whole closed chamber. So more you decrease the volume of the chamber, more easily you can reach the saturation level. So statement C is also correct. Thereby all ABC statements are true. So that's all for today, guys. Hope you learned new concepts regarding each and almost all the topics in your syllabus are covered in this kind of a discussion rather than separately doing MCQs by lesson wise. If you are quite satisfied with the theory backgrounds in all the lessons in physics, this session would be quite useful. I hope you guys would review these MCQs later onwards and write your own reviews in separate notes. During the next session, I'll come up with various short tricks so you could solve MCQs which should appear after 21 up to 30, because then onwards the time is critical to solve each and every MCQ problem. And short methods are quite very much helpful. So thank you for listening for today's session, and see you in the next video. Thank you very much. Have a nice day.